Assalamualaikum and hi. So today we are going to present about our mini project for the subject embedded system, which is EDI4153, and our project is about password protected parking system at apartment, and we are from group 6. Okay, let me introduce to our group members, which is I'm Nurdana Atrah binti Asmadi. My matrix number is X66418. And my friends is Nur Afini binti Muhammad. The matrix number is X66537. And the lastly, Siti Nur Shakina binti Jansi. And the number matrix is X67708. So, the next slide is about introductions. The password protected parking system is an automated system for apartment parking facilities that use a unique password protected barcode card to regulate vehicle entry, display driver's name and car plate number.
The process starts with the initialization of important components such as keypad, LCD display, and servo motor. The keypad is used for user input, the LCD display, visual feedback, and instruction, and the servo motor complete the mechanical function such as opening or closing gate or lock. This initialization ensures that all components are operational and prepared to carry out the next action. After initialization, the LCD displays the command "Touch your card," asking the user to interact with system. While it suggests card-based authentication, the system here mainly focuses on password input. This message asks the user to enter their credential. The next step involves the user to enter their password using the keypad. The enter password will be verified against previous saved credential. The flowchart display for specified password is set up for specific user. If the enter password match one of these predefined, if the enter password match one of these predefined settings, the system identifies the user and allows them to process. This verification stage ensures that only authorized users have access to system function. If none of the password match, the system loops back to request password input again. After successful authentication, the servo motor performs the specific action, such as turning clockwise or counterclockwise. Each operation may represent lock or unlocking gate. The process in after the servo motor operation.
Welcome to our presentation on the automatic parking system for apartments, a smart solution for managing parking spaces, especially in airport placement. Our project started with coding in MPLAB, a development environment specifically designed for embedded systems. The coding involves configuring microcontrollers to handle multiple tasks like managing sensor, display, and motors that drive the parking system. Let's take a closer look. Code breakdown. The code starts with including essential header file like HTCH for high-tech libraries, along with PWMH, LCD, ADCH, and TPH. These are crucial for enabling functionalities as motor controls, display output, and log-to-digital conversion, and TPH interaction. We already initialize all ports with 0 to ensure hardware start in a null state. The trace registers are configured to set port as input or output depending on the hardware connection. For instance, choose A, choose B, and choose C is defined which pin are input set as 1 or which are output set as 0. Now, let's dive into the code logic responsible for security and server control in our automatic parking system. This section handles the following functionalities. First, the password authentication. The user enter a password using keypad. The code comprises the interface via the preset system password. If the input match, the system proceeds to unlock the magnetic lock. An incorrect password triggers an error counter and the user is prompted to try again. Next, for part of magnetic lock mechanism, once the password is validated, the magnetic lock is deactivated, allowing entry or exit. And then, if an error is detected, the lock remains secure to prevent unauthorized access. For the part of servo motor control, upon successful authentication, the servo motor is activated to move the barrier to the left or the right, allowing the vehicle to pass. The motor then resets its position to prepare for the next vehicle. And then we are going to part of the error handling. As you can see at the coding, the system accumulates errors for each incorrect attempt that will enhancing security. It will also provide feedback to the user with bits or message displayed on a LCD. The code is structured to ensure both functionality and security. Use loop to continuously check for password correctness. Conditional statement control the flow of operation, ensuring the magnetic lock and servo motor work in sync. The relay commands toggle the magnetic lock while servo commands control the gate movement. The efficient integration of password security with mechanical operation will ensure only authorized users can use the parking system. Here is the few example of password of user. First, Nordiana DEV8831. with a password of 123456. And then the second one is Sakina Jansi. The plate number is SAB4587 with a password 64654 324. And the rest is, as you can see, is on the slide.
First, we are going to simulate this PIC kit. The LCD will display touch your card, which it requires the user to touch the card. For this system, we make 4 password for 4 users. We will try 2 user of password and a wrong password. So let's try for the first password.
Okay, for the first password, it is 1, 2, 3, 4, 5, and 6. So it will display the name and the car plates, and the servo will rotate as it assumed as the bar gate to close and open the gate. So let's try to the second one, which is the password 456788, and it will display the name and also the car plate, and the servo also will rotate clockwise and counterclockwise as it assumed to open and close the gate. Okay, next we try for the wrong password, and it will display error, and it requires us to re-enter the exact password. Thank you. So that's all for today. Thank you for watching.